Hello friends, this video on classification of elements part 21 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 20. Now we'll introduce a new topic called electronegativity. Please note, till now we have done electron gain enthalpy. Now we are understanding electronegativity. And this is the ability of an atom in a chemical compound. Please note this value or number varies based on the compound element is in. This is the ability of an atom in a chemical compound to attract shared pair of electron towards itself. Right? And electronegativity is not the property of atom but the property of atom in a molecule. Please note, electronegativity is not a property of atom but property of atom in a molecule. Also, it is not a measurable quantity. It is not something like energy which you can measure in joules, or it is not a measurable quantity. It has some numerical scales actually. There are a lot of numerical scales available to measure the electronegativity. Pauling scale is the one which is widely popular, and we'll learn this Pauling scale. So what this guy has done is this guy has assigned arbitrary value of 4.0 to fluorine, because this is something which is expected to attract electrons the most. Please note, electronegativity is nothing but ability of an atom in a compound to attract electrons, right? So atom attracting electrons in a compound. So please note, three words are very critical here. Atom attracting electron in a compound. So there is no actually, you can't measure it. So there is a scale to measure that, and fluorine is given maximum 4, and cesium is actually the minimum value of 0.7. Right? It's a table for this. If you see, fluorine is 4, oxygen is 3.5. Like this, they are given the values. And if you see this value in a given period, it increases if you go from left to right. If you go down, it decreases. Please note, there is no anomaly in the trend. It's a normal trend. If you go in a period, the electronegativity increases, and if you go down in a group, the electronegativity decreases. Cesium has the least electronegativity value, and these values, just he assumed that this value is 4, fluorine is 4, and relative to fluorine, all these values has been derived experimentally. Right? So when I say that the electronegativity is something which is based on the compound, for example, hydrogen can have HH, hydrogen can be, you can have H2, right? So where H is a covalent compound, it can have HCl also, or it can be HF also. In this case, HH, if you see, if you talk about HH, so HH, if you talk, both these guys, right, will equally attract each other, right? So the molecules of this guy, electron of this, let's suppose this is hydrogen 1, hydrogen 2, the molecule of hydrogen, the hydrogen atom 1 will attract hydrogen atom 2 electron, and hydrogen atom 2 will attract this guy electron, right? And the power will be almost same. The power will be almost same. So the electronegativity will be same actually. There won't be much difference. But if you see HCl now, chlorine has more electronegativity. See, in this case, hydrogen, hydrogen, if you see, this is one electron, they'll pair up. And these electrons will share equal time with both the hydrogen. But in case of chlorine, if you see, I'll draw the Lewis structure. 1, 2, 3, 4, 5, 6, 7. This guy is 1. They'll pair up, but this electron, if you see, will spend more time with chlorine. So if you see, this electron will spend more time with chlorine than with hydrogen. So it will be something like this. Yeah, hydrogen here, chlorine here, something like this. But this guy, this electron, the extra electron which is shared now, is sharing more time with chlorine. So hydrogen will develop partial positive charge and chlorine will develop partial negative charge. Correct? Why? Because this electron is spending more time with chlorine. So we see the electronegativity of chlorine is more here than hydrogen. Correct? Because chlorine can attract the electron, the shared electron which we have more. Correct? If you talk about HF, fluorine is all the more electronegative. So what fluorine will do is, fluorine will take the electron completely. So it will become H plus and F minus. So here it will be like this, H plus and F minus. Totally separate, two different ions it will create, and the fluorine will totally absorb this electron, hydrogen electron. It is so powerful, right? If you see water, if you see H2O, here also, right, oxygen has more tendency to attract the electrons and hydrogen has less tendency. So hydrogen will get slightly positive charge and oxygen will get slightly negative charge. That's what we call polar covalent bond. So if you see in this case, what I'm talking about is, we have an element, we have a compound for water here, we have here HF, we have HCl. So we have an element, we have compound, and we're talking about the capacity of these elements, hydrogen, chlorine or fluorine or oxygen in these compounds to attract the shared pair of electron. And that's all electronegativity is all about. So we say that it is all about the capacity of an atom in a compound, where it's a water compound or in a molecule, right, water molecule or a hydrogen molecule or or HCl molecule. In this molecule, the capacity or the property of the atoms that are part of this molecule is to attract electron towards itself, and that is called electronegativity. Hope you understand. Example, in HCl, chlorine is more electronegative than hydrogen, so it will attract electron, the shared electron, the one electron shared which they have shared, more toward itself. So it will be something like this. It will be the extra electron, right, which he has, example 1, 2, 3, 4, 5, 6, 7, it had. The extra electron which it has got now, the chlorine which is shared, that guy, this extra electron which is from hydrogen, will spend most time with chlorine than with hydrogen. But it will also spend some time with hydrogen, that's why they have covalent bond. But chlorine will attract more. In case of fluorine, HF, it will attract so much that it will pull out the electron from hydrogen and become ionic bond. In hydrogen also, water also, you see there's a polar covalent, and that's all electronegativity all about. In case of electronegativity, we talk about a molecule. In molecule we have elements, and these elements have a property to attract shared electron to one itself. So please don't get confused between electron affinity and electronegativity. Electron affinity, I told, is something, but it is for an isolated atom to attract electron. So there is, let's suppose, chlorine molecule which has 7 outermost electron. It has some affinity to attract electron and become Cl minus, and has 8 electrons in the outermost shell and becomes stable. So this is called electron affinity. So when we talk about electron affinity, we talk about isolated atom. In case of electronegativity, we talk about a molecule. For example, in case of HCl also is a molecule. In this case, chlorine has affinity to attract the shared pair of electron toward itself, so it becomes negative. It gets a partial negative charge, and this gets a partial positive charge. That is electronegativity. So when we talk about electronegativity, we talk about a molecule. Inside the molecule, the atom's tendency to attract shared pair of electron. Please note, it is shared pair of electron. In both cases, they are attracting electron, but in this case, it is an isolated atom that attracts electron. In this case, it is atom in a molecule that attracts shared pair of electron. Electron affinity, it is measured in joules per mole or kilojoules per mole. This guy is measured in number. It doesn't have any unit. It is a property of, if you see the electron affinity, as I told, is a property of isolated atom, and electronegativity is a property of bonded atom. right? An atom has absolute value of electron affinity. So when I talk about chlorine, chlorine will have a specific value of electronegativity irrespective of, which atom or molecule I'm talking about, which molecule I'm talking about. Chlorine will always have one fixed number of electron affinity. But if you talk about electronegativity, for example, hydrogen, as I told, in case of HCl or in case of HF, in case of H2, right? The electronegativity of hydrogen is different in all these cases. In water also different. It's all same hydrogen atom, but the electronegativity varies based on the molecule. Correct? And electron affinity doesn't change regularly in a period of group, but this change regularly in a period of.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.